Hello, Global Stars. Welcome to this Python full course part 9. So in this part 9 that we are seeing in this 2025, we are going to be understanding all about the object-oriented programming in Python, which is a book in Python. So what am I saying in this? The concept about the object-oriented programming that we are going to see inside Python programming to understand. So we are going to be seeing classes, understand what are classes and how to create classes and why are we using the classes. We understand the objects, how to create the objects and the functions of the objects. And also we are going to be understanding inheritance in Python, polymorphism in Python, encapsulation in Python, and data abstraction in Python. And if you're watching this, if you're stumbling on this channel for your first time, make sure to please keep a like in this video, subscribe to this channel, and also share with others. And one exciting thing I'm going to tell you is that make sure to watch till the end, because at the end of this video, we have exciting question and answers that are there to help you to build your career, to help you to be able to prepare yourself for even for interview, to understand more about these some questions and answers based on this particular topic. So without saying anything, let's continue to see how we can be able to do this. So the first thing we are going to be seeing is Python classes and objects. We are going to be understanding what are Python classes. When we talk about classes and objects, this is object-oriented programming. So Python is an object-oriented programming language, or I say almost everything in Python is an object. That is one thing you should put in mind, and with its property and methods. So a class is like an object in constructor. I'm going to explain to you when we shall we are understanding it more. So meaning that or a blueprint for creating objects, because you don't create objects without the class. So now in detail, let's understand what is a Python class. A class is a collection of objects. Can you see? Means that collection of objects forms a class. So classes are blueprints for creating an object or creating objects. A class defines a set of attributes and methods that the created objects or instance, because we call the object as an instance of a class, means that you're instantiating the class, can have. So some of the key points we need to understand in Python class is this. Class is created by the keyword called class. Means that whenever the interpreter, whenever it wants to understand that is a class that you're working on, it has to see the keyword class. And then we have the attributes. Attributes are the variables that belongs to a class. Don't worry, sit tight, because when we start doing it practically, I'm going to explain to you what these things are for you to understand what I'm saying. The next thing we are having is attributes are always public and can be accessed using the dot operator. You're going to see it. Don't worry, sit tight, don't stress about it. Then creating a class, as I said, in order for you to create a class in Python, we have to use the keyword that is called class. Because when you encounter the keyword class, it knows that we are creating a class. Now, the next thing we are going to be understanding is what is an object? What is an object? You get it? So an object is an instance of a class. It represents a specific implementation of a class. Before even going to explain everything about an object, let's try to first of all see how to understand to create a class on our this in our interpret in our development environment. Let's try to create a class in our development environment to understand what this class is all about and what I've just explained. And before we continue, if you haven't liked this video so far, what are you waiting for? Please click the like button. Subscribe to the channel, because it is very helpful. It's going to build a career for you, to help you to be a career this 2025 to become a Python developer. Then you're going to have a great pay. It is a good thing, right? So just click the like button, share with others. You can share on all your social media platforms. Share with your families, your friends, your siblings, your groups. Please share to be able to boost the algorithm of this channel by clicking the like button. And when you subscribe, just hit that notification bell to get notified whenever we upload new videos. So it's going to help you to get updated, because this is a full playlist for a full Python course. And this is the part 9 of it. And the part 10 is going to be coming. And if you haven't watched the part 1 to this part 10, don't worry. Just go backward inside. This is at Code Global. This is Code Global. At Code Global, you're going to be able to do what? You'll be able to watch that particular, watch the part 1 to the others, and even shorts that are inside this video. So what are we waiting for? Let's try to see how we can do. Make sure to keep a comment in the comment section if you've subscribed, to say, I have subscribed. Okay, let's continue. So creating a class. Now, the first thing we are going to be seeing inside our development environment, where we are going to be like typing the code and writing the code. And for the sake of time, I've just prepared everything. I'm going to explain detailedly for you to understand. I've put hints. These are all hints. When I say hash, means that when you're printing, this will not affect it will not affect the work. These are just, it's like comments, hints that I'm giving you to understand what is the step on whatever we are doing. So the first thing we are creating is, let's assume that we are having what? We want to create a class that is called dog, because we want to talk about dogs. So I'm just creating a class. The class name is dog. So you use the keyword called class in order to create a class, then followed by the class name. Whatever the name you're given, you can create a class person. You can create a class, whatever it is that you want to create that particular class, depend on you on what you're working on. So now inside, I'm given one. I'm creating a class attribute, and this class attribute, I'm calling it a species. So the species I'm saying that is a canine cat that I'm creating Canaan. So I'm saying the species, the dog species under this particular species. That is what class attribute. So this is just what I explained to you about the class attribute before. This is it. If you don't remember it, please just pause this video, rewind it to where I was explaining the notes where I was explaining, and listen to it again to understand what I said. It's the class and the class attribute and how to work. As I said, a class is what? A class is a collection of objects. And I say a class is a blueprint, to define an objects. And we say inside this, we also have class attributes. We have attributes, isn't it? That is what happened. So when you look here, this is a class attribute that we have just created, we have just declared here. And coming here now, we want to initialize. We want to initialize what the name, H, and the H attribute. So these are the attributes I want to initialize for this particular. And we use this. Remember, we saw this def keyword when we were dealing with functions. So also here we are going to be using it to also def. We are having the init method. This init method is used to what? This init method, we are using it to initialize the what? To initialize the particular attributes that we want to pass for this particular dog class. You get it? The attribute that we want to be able to pass. So you see, this I say what? The init method initializes the name and age attribute when a new object is created. Because that is what it does. When a new object is created, it initializes that for us, which is beautiful. And then we have the self.name. Name. I'm saying self.name. What is this? The instance attribute. This is an instance attribute. This self, this is pointing to the object of that particular class. It points directly to the object of the class. This self.name, I'm going to explain it to you in further very soon. I'll give you to understand. It points directly to the object of that class. And you see, we have self.name, and we say we use a dot operator, isn't it? Good. So the point is the instance attribute, and then self.h, which is what it is pointed to the particular word. It's pointed to the object of that class. This is it. So we have instance attribute, which is beautiful. So this is how you can create a class. This is just a simple class that we have just created. We are going to be seeing more as we go forward to understand how to create a class and how to go forward. But before doing that, I just want to show you how you can be able to create a simple class. You can decide to create a class person. You get it? You create a class person, and in this class person, what you want to see, for example, the species, it might be white or it might be black. You might put here, no, let's say species, you might put here white, or you might put here black or Caribbean, or you get it. It depends on you how you want to put it. And then now you come here, you want to the particular person that you're the person that's the class person, and whatever the species, the attribute you're given here, the name of want to get the name and the age of the person, whatever. So say self.h is going to take the name is going to give the name of the person. Self.h is going to, because this self, it is pointing to the object of that, directly to the object of that class. Hope this is clear. Let's continue. So as I said, it is clear about the class. Now it's an object of a class, a Python object. So what is an object? An object is an instance of a class. It represents a specific implementation of the class and holds its own data. That is one thing you should understand. So this object consists of what? It consists of the state, the behavior, and the identity of whatever that is in that particular class. So it represents by the attribute and reflects the properties of an object. The behavior it represents by the method of an object and reflects the response of an object to other objects. And the identity, it gives a unique name to an object and enables one object to interact with other objects. So now creating an object, how do we create an object? Creating an object is pretty simple. It is pretty simple for us to create an object. So creating an object, We simply do what in Python involves instantiating a class or to create a new instance of the class. This process is also referred to as object instantiation. Now, coming to the next thing I told you is the self parameter. This self parameter you're going to be seeing everywhere as you're walking. The self parameter is reference to the current instance of a class, means that it's pointing to the current object of the class. As I told you that an instance is the same as an object of that particular class. So it allows us to access the attributes and methods of an object. And then the init, as I told you about the init method, that's the first thing when you are initializing what? The init method is the constructor in Python, which automatically called when a new object is created. So it initializes the attributes of the class. That is what this init method does. You get it? So now let's try to see how we can be able to know how to create an object of the class. Then we are going to see now a full program how we can create both. Let's try to understand. So now creating an object in that doc class, the doc class we had before, we want to create an object of it. So I'm just going to create an object. I give a name. This name that I'm giving here, this name is my object name. It can be anything. So I use doc1 because I'm working with docs. So I just create an object. I say the object is doc1 and I'm assigning what? I say doc. Now I'm assigning the class. When you say doc1, this is the class name. It has to be exactly as your class name. And then what is the type? What is the doc? I'm calling the doc. The name I'm giving is body. And then the age, I'm saying 3 years old. You get it? So what is it that I'm doing here? This is it. I've given it here to make you to understand. I say create an object of the doc class with name as body and the age as 3. That is just what I am doing here. So the object that I've created here, what is the object? The object is doc1. Because I'll need to use this object to be able to call the instance of the call the this in the to be able to access the instance attributes. You get it? All the instance attribute, if with this object I've created, I'm going to be able to use it to call or to access the instance attribute. So now what is the next thing? Next thing I want to print. Now I want to be able to access those instance attributes. What is it we are going to do? If I say print doc, if I say what? I say doc.name. Remember we say we use the dot operator in order to access. Right, that is what I explained from the beginning. You can go back and read the note and pause and then go backward again and listen to the note I just explained from the beginning. So what are we having? I say print doc.name. What am I saying here? I say I want to access the instance attribute name of the doc object. So automatically what is going to print is going to print me what? Body, isn't it? And if I say print doc.species, means I can also access the species of it. That particular species I can also access. And the species was Kenan, right? So you can access the class attribute species of dog object, dog1 object. Now I say print dog1.age. So it's going to access the class attribute age of the dog of the what dog1 object. Meaning that if you run this particular thing, it is going to give us what? If we run it, it is going to give us in that format because we've created the object. But now for us to do that, I need to have what? We need to have the So now this is the full program as we had. The first one was creating the class. That is it. I've explained how we created this class. Now we are creating the object because through the object we can be able to access the attributes of this class. All the even the things inside this class, we can be able to access them using what? The instances of this class, we can be able to access them using what the object. So creating this object that I've created, which is a dog, I said, and then I've passed here, this is the class name exactly as it is in that class. The name we gave two in this class that we are having here, we have two things that we have specified, two attributes that we initialize here. The initialize method that we added here, which is what initializes what the name and the age attribute, isn't it? Of that particular class, attribute objects of that class. So what is going to happen here is this. When I say print dog, and I've passed here is body and the age is 3, I said dot name. Let's run this piece of code and see. You see? The first thing is that what I want to print the name. The name of it is, so you take the object dot the attribute name is going to give us body. Then the object dot the species name. Remember in that particular class we had a species, which is a Kenan. So it's going to give us a Kenan. And then the object dot age is going to give us 3 years old. So hope this is clear. Let's continue. So now this is another program. The next one we are going to be seeing in this program that we are having here is creating a class and object at once. So now we are seeing another class that we are going to be creating. So the thing we are giving is saying to create a class, we need what? We need a keyword that is called class. And then the name of the class I'm given is person. And remember, when you create a class, you have to edit with a colon. Just like what how we're dealing with function and other things. And then coming out to initialize. Remember what you were initializing what? Remember what I told you. We are here to use the init method. This init method is going to initialize the attributes of that particular class, isn't it? So we have what we have of the objects of that class. We have the name and the age. So the serve operator is pointing. We say this serve attribute is pointing to the object. It's calling the object of that particular class directly, right? That is what it is doing. So serve.name is name. Serve.age is age. Means that the age of the person and the name of the person are two attributes that we are having. Now I'm creating now the object of that class because we want to access this particular attribute of the class. In order to be able to access those attributes, we have to create an object of the class person. So I'm creating my object. I gave my object name as a P1. That is, I'm given the object name. My object name I'm given here is P1. So this P1 now is just the object I'm creating. I'm assigning it to, remember, the person. Person class we have to put there because the name, spelling, everything should be the same. Then I'm passing now what? I'm passing these parameters. The attribute that we get here is name and age. So the name is John and the age is 36. Now what am I doing here? I am simply creating the object of the person class with name as John and age as 36 because without the object, remember we said what? A class is just like a class is the collection of objects. You get it? The objects, with the objects we can be able to access the members of the class using what? The attributes of the class using what? The object. So now we want to be able to print this. How do we print this message? We have to use the object dot that particular word instance attribute. So to access the instance attribute, this instance attribute you're having here, which the name is John, the age is 36, we have to use what? Use the object, which is P1. So this is what happens. You say what? P1.name, we're using the dot operator to access it. So access the instance attribute name of the P1 object. That is what this is doing. And also we are going to access the instance attribute age of P1 object. So we are accessing it. So therefore means if I run this piece of code, that is going to give us what? We run this program, it's going to give us as John and 35 because we have access to get the John, the name, to the object dot name, it gives us John. Object dot age gives us 36. So hope this is clear. Okay, now this is another scenario we are having here. We are having a class that is car. So now we are having a car. For example, car got different attributes. It got the model, it got the price, it got the color. If you want to buy a car, you have to check all this. There are a lot of them there. I'm just taking sample of them. You get it? So the class is a car. For example, it's just like how you can have a class vehicle. The vehicle means you can have different type of vehicles. You can have Audi, we can have what? Tesla, we can have what, you can have different attributes. That is for the top when you're dealing with vehicles. You can have trucks, you can have what vans, you can have different things. But now we are dealing in terms of car, just a particular car, and in that car we got also what we got different attributes. This is what we used to remember. This is the step that you know that this is initializing what we have the init method to initialize the attribute of the object of that class, isn't it? And then the serve operator, we have what? There are three things we have passed there. We have passed three. We have what? We have the model, we have the price, and we have the color. So the serve, we know the serve operator, this serve attribute is going to what? This is pointing directly to the object of that class. We know very well, so we understand it. So serve.model is the model. Serve.price is the price. The serve.color is a color. So these are the attributes of the class, which is model, price, and color. Now, I'm now, what am I doing here? I'm having one other function here, which is what? The display function. I'm declaring a display function here, which is going to display the self for us. So in this, what are we saying? This display function means I'm going to see these are different ways you can write, or can be able to write. I've shown you two different ways. This is another way in which you can be able to define our class and write and do everything. So now I have the def, I say display self. So I'm displaying this self means everything that it has given, I'm going to have everything here, isn't it? So print, I'm having the model. The model is what? Is self.model. You get it? The model, these ones in double quote, these are just things I'm writing. So when I'm printing, it should be able to display blindly, isn't it? Because these are strings that will blindly display. But now when it says self.model, meaning that word, when I'll be calling this display method, what happened? It is going to Go back now to what to pick this, isn't it? Now we say print model is self.model. The price of the car is self.price, means whatever the model we are giving here is going to display the model. Whatever the price is going to display it for that particular class. So because the attribute is in that class, and then print the color of the car is self.color, means that it's going to choose whatever the color we have provided, that's what is going to pick it up and display for us. So now I'm coming to create the object. I've created the object that is called C1, just like C for car, and then C1, that's my object name I've just created, and in it I'm assigning. Remember, the name of it, this should be the same as your class name, because you're creating the object of the class car. And in this class car, you're having three attributes in it. We have the model, and my model is a wagon. I'm saying the car is wagon. And the price of that car is what? Is $600,000. And the color of it is white. So I'm having a white, I'm having what? A 600,000 white is in wagon. You get it? So that is what it's going to do. Then after that, we are going to use the object now to call the display method. You call this display method says C1.display. What happened? Let's print it. Let's run this program and see. So you see the model, the first thing there, the first attribute was a model, which is a wagon, and then the price. Let me just shift this way. The price of it, you see the price is $600,000, and then the color of the car is white. So can you see? This is how you can be able to. Hope this is clear and understood. Let's continue. So that is it about Python classes and objects. Hope it is clear. Now we are going to be seeing the next aspect in this our program for today, which is Python inheritance. We're going to understand what are inheritance in Python. And before continuing, if you haven't subscribed to this channel, guys, what are you waiting for? Just click that subscribe button, and just when you click the subscribe button, you click the notification bell and select all, so that you get notified whenever we upload new videos. And if you have not liked this video, guys, liking the video is going to boost the algorithm of this channel. It's going to at least recommend these videos. So please just try to like it, and you can drop a comment in the comment section, share with others, share on your social media platform, and then tell me about your experience as you're practicing in the comment section. So let's continue. So we have the inheritance allows a class, which is a child class, to acquire. We know what it means, inheritance, even in normal day life, means that the child is going to inherit the properties of the parent, right? For example, if I give birth to a child, to give birth to a particular child, maybe if you're fair, that child might be fair like you, or if you're dark, the child might be dark like you. Those are the properties the child is inheriting from you. If you're fair, your husband is dark, maybe the child will inherit the complexion of your husband, and then maybe he can inherit your eyes. He can inherit your nose. Those are attributes on you, properties on you that the child can take, and then inherit what different things from different people. It's the same thing that is happening here. So in real life, it's the same thing is happening. So inheritance allows a child class to acquire properties and methods of another class, that class which is a parent class. So it supports in hierarchical classifications and promote code reuse. That is one thing. The most important use of inheritance is reusability of code. Meaning that instead of defining the same thing in the class, the child class or the parent class multiple times, for example, you can have a project or a program you're running that has many classes. So instead of keep rewriting the same thing, we can just reuse it using inheritance property. This is why inheritance is very important. You get it? So the types of inheritance that are there that we are going to be seeing is single inheritance, that a single class is going to inherit from another single parent class. We have multiple inheritance. A child class, that is another class, inherits from more than one parent. For example, anyway, we are going to be seeing all these things and see how it works. Then we have multi-level inheritance. A child class inherits from a parent class, which intends inherit from another class. Then we are also going to be seeing hierarchical inheritance, which is multiple child classes inherit from a single parent class, and hybrid inheritance, which is a combination of two or more types of inheritance. Hope this is clear. If you have not liked this video, please click the like button to like it now. And as I said, remember to watch till the end, because we have exciting questions and answers that will help you to prepare yourself for your interview and to help you to understand more of So now we are going to be understanding the various types of inheritance. As I said, we have single inheritance, we have multiple inheritance, we have multi-level inheritance, we have hierarchical inheritance and hybrid inheritance. We are going to be seeing all these. What is a single inheritance? A single inheritance, as I said, is just when we have one single class, that is a parent class, and we have a child class. And that child class can inherit what the properties, I mean the attributes, you get the properties or attribute of all of that particular parent class. So now look at what happened. This is a class. We have class employee one. And this is a class that we have just defined here. We have declared a class. That is our employee one. And this is a parent class, which is parent employee. For example, in a company, we have employee. Then I'm initializing what the method in our employee. One of the attributes we have here, this is initial. We use the init method to initialize what the attributes of that particular class. So I want to know the name in the parent class, means all the employees in the company. We want to know the name, their age, and the salary. So we know normally the self.name is equals to name. We are assigning the name to either age. So this is just like pointing to the objects of that particular class, isn't it? The salary. These are the three things. Now I am also having another class that is a child class, which is child employee class, which is inheriting from which class? It is inheriting from the employee one class, which is a parent class. So you need to specify like this: where does this class where is it inherited? So that it can inherit what? All these things. If you see, it's going to inherit the salary, the name, the age, everything is the properties here. That whatever we have defined here, whatever the things we have given here, the attribute, whatever this particular child class is going to have, whatever it is having here plus what it is having here can inherit from this employee, the parent class. You get it? This is how you have to represent it so that you show that it has to inherit from that class. Means all the attributes here, the properties here, this child class, child employee is going to inherit. So I put the name like this so I'll make it clear and understandable. So I'm initializing the same thing, name, the age, and you see now I've added something also, which is the ID. The attribute of added one and other attribute, which is a ID. Now I'm creating an object. The object is EMP1, employee one. I'm just creating an object which is EMP1 of what? Of this particular class. So when I create this object, I say employee. This is for what? This is for the parent class. And I'm passing. Look at what this up. Just look at it very well to understand how this child class is going to inherit from the parent class. Now this object I've created is the object I've created for the parent class. Can you see? Employee one is the name of the parent class. And what are the attributes here? We have Suma. We have the age is 23 years old. The salary is $50,000. So there is just somebody somewhere that is called Suma. Is 23 years old and is earning $50,000 per month. Now, this child class wants to inherit the properties of that particular parent class. So I didn't create any object of the child class, if you look at it very well. So I'm going to use the same object and I'm going to call it to be able to get it. So I said print employee's name, emp dot is emp1, the object dot the name, the object dot the age, and the object dot the salary. Isn't it? Because it's giving us the salary. Now, because it has inherited the properties from there, if I run this, look at what is going to happen. Can you see? Employee's name is Suma. Employee's age is 23 and the employee salary is $50,000. Why? Because it is inheriting, well, this is single inheritance, that it is inheriting from where? From this child class is inheriting from the parent class. And this is whatever the things we have given here. So it is able to print it. So if you look here, the second one we are having is the multi-level inheritance. What did I say is multi-level inheritance? That a particular class is going to inherit from a class that is in turn inherited from another class. Can you see? Multi-level means that this child class employee to inherit from a class, that the class also is in turn inherits from where? From this other class. That is multi-level, means you have different levels of different level inside. So I'm having a class employee. This employee, I'm having what? Three attributes: a name, age, and salary. So as usual, self.name is name, self.age is age, and the salary. Now I'm having another class that is a child class that is inheriting from where? This class employee, which is a parent class. But this is a parent class of this child class. This class like this is inheriting from this class. That is why you see in here it is stated employee, means it's inheriting from this employee class. It inherits all the same thing: the name, the age, and the salary. All the attributes of that class inherit. And now if you see, This other class now, the child employee 2, is inheriting from the child employee 1. And remember, child employee 1 is inheriting from employee, which is a parent class. And this child employee 2 is inheriting from also the child employee 1, all the attributes that this child employee 1 inherited from this employee parent class. Can you see how it is? The name, the age, and the salary. Now, I'm going to create what? I'm going to create this in create what? Attribute. So, employee 1, look at what I'm doing. I'm creating what? 2 objects here. The first object I'm creating for the parent class, which is employee. I say the name is Hashit. The age is 22 years old, and the salary is $1,000 per day. Now, for employee 2, look at employee 2. I'm creating also what? An object for employee 2, which is I'm creating an object for employee 1. Sorry, not employee 2. For this employee 1, for the class employee 1, you see employee 1 class, I'm creating an object. So I've created an object for employee for the master class, which is the parent class, and now for the child class, which is the employee 1 class, and the name is Ajun. The age is 23 years old, and the salary is $2,000 per day. Now, because we want to access everything, right? For us to access it means for the first part is going to access. I'm going to access what? I want to access now in the first part. One I'm accessing is what? Print employee's name is employee.name. Using what? The one I've created for the parent class, isn't it? This is the object I created. So object is emp1.name, emp1.age, and emp1.salary. Then coming now for the employee 1 child class. So I created the object which is emp2. So that object now is I'm going to access now the attribute of that class by emp2.name, emp2.age, emp2.salary. So when we run this particular program, as it is like this, if I run this program, this to show you the mid-level means that what? It is going to display all those things for me. So you see, if I run it, you see, this is employee's name is Hashit, 22 years old, and $1,000 a day. This is the second part. Employee's name is Ajun, 23 years old, and $2,000 a day. So can you see what I said? With this inheritance, it helps because I told you inheritance, the main important function of inheritance is reusability of the code, which it helps to reuse the code. That is one thing that is very, very important. Reusability of the code. So we can reuse the code. You see, reusing it without what defining everything. So you see, we can get the output. Hope this is clear about the mid-level, this is multi-level inheritance. Let's continue. So the next we are going to be seeing is the hierarchical inheritance. So with hierarchical inheritance, remember what I explained. I said it is a situation where multiple child classes are going to inherit from a single parent class. That is why we see we have here the parent class we are having here is employee. Then we are having this attribute, the name, age, and salary that we are pointing to. The object is pointing to it in the class. Now we see the employee 1 is also inheriting from the employee class, which is the master class, the parent class. Employee 2 is also inheriting from the parent class, which is employee. If you look at it, all of them are inheriting from this parent class. That is why you see in their argument here, the parameter, they are having the word, the parent class name. So they are inheriting the same thing, the name, the age, and the class. Everything, that is what they are inheriting from it. Now, if you see, when I create the object of the particular class, the object of that particular parent class is what? This is it, emp1 I've created, which is employee. I've created 2 objects of it. So you see, employee means this one is in one of it. This is inheriting Rashid, 17 years old, and the salary is $21,000. We have employee 2 is a new object that I created. Also, object is for the employee class. So both of them are what? Both of them, the 2 classes are what they are. They are inheriting from that particular parent class called employee. That is why you see the name is all employee here. So this is calling for the other child class. This is calling for the other child class. So you see we have none, which is what? 23 years old, and the salary is $20,000. So if I'm printing here, you see I have print, the name is employee1.name is going to pick this. So it's inheriting from that particular parent class. This also is inheriting from the parent class. We run this particular piece of code. You see, we are going to have it as here. This is the output. Employee's name is Rajit. The age is 17 years old. The employee salary is $21,000. And then we have the employee name for the second one, which is none. So you see the objects I've created for the two. You get it to be able to call all these things. Hope this is clear. It's very beautiful with inheritance, right? So now we are going to move to another thing. So the next thing we are going to be seeing here is polymorphism, Python polymorphism. Now, what is polymorphism? Polymorphism allows the methods to have the same name but behaves differently based on the objects of the object's context. So it can be achieved by what? Through the method overriding or overloading. We have method overriding, that is overriding a particular method or overloading a particular method. So the type of polymorphism that we are having, we have two types of polymorphism. We have the compile time polymorphism and we have the runtime polymorphism. So what is compile time polymorphism? This type of polymorphism is determined during the compilation of the program. When the program is compiling, so it allows the method or the operators with the same name to behave differently based on their input parameters or the usage. So it commonly refers to as method or operator overloading. That is one thing about it. So method overloading occurs in the compile time polymorphism. The next thing we are having is what the runtime polymorphism. This runtime polymorphism is a type of polymorphism which is determined during the execution of the program, when the program is running, and it occurs when a subclass provides a specific implementation for a method already defined in a parent class. So, which is commonly known as method overriding. So, it means that it overrides a particular method. So, we are going to see to understand how it works. Okay, so we are going to be understanding polymorphism example, as I told you. And remember, one thing is that I have written these codes, I've written them to save time as we are going, not to make the class too long. But please make sure to pause these videos and type it yourself. Type. Try to understand it and type and write the same way, because I'm just trying to save time to help you also, not to see the class too long and boring. You get it? So now, as I spoke about polymorphism, there are two types of polymorphism, the runtime polymorphism and the compile time polymorphism. As I said, in polymorphism, it allows what? In the compile time is a method overloading, and then to overload a method, and the runtime is method overriding. So if you see here, we are having a class that is employee one, and in here we are having many methods. Okay, we are getting many methods here. You see, we have name, which is saved. The first one, print Hashid is his name. The second method is the salary. The second one we are having is the salary. The third one that we are having is the age. The second function, we have different functions inside. Method is the function. So we have the age, which is 22 is his age. And then come to the next class. We have another class that is employee 2. This is employee 1. Now employee 1, employee 2. We have the name, we have salary, and we have age. The same attributes, the same function names are the same thing we are having inside. Isn't it? Now, we have now a function where we are having the object of the class. So the object, which is obj, I've just given the name obj, which is object.name function, the name method. So we are calling the name, the salary, and the age, the three functions that we are having in the particular classes. These are the 1, 2, 3, 1, 2, 3 also. So we are calling it, and then I'm creating now what? I'm having an object here, which I'm having is an object employee 1 for the employee 1 object that I'm having here. I'm given object employee 1, that is the name of the object, and I'm given what? The employee 1. For employee 1, I've created this object. Employee 2, I'm created this object. So I'm having now to have it, you see the function of that particular object, so the form object employee 1 and object employee 2. What are we doing here? Let's run this and see. Let me explain it for you to understand. So we run this piece of code. You see, it's giving us Hashid is his name, and $13,000 is his salary. 22 years old, 22 years is his age, and Raul is his name, and this is the salary, and this is his age. Let me bring it this way to make it a little bit. So you see, what happened now here is this. We are having it. So we are having polymorphism, the method overloading method. You see, because number one, you see, overloading the methods is the same method that we are having. Salary name is a method, and the same thing name here. Salary here, same thing. So in the compile time, what happened? The method overloading, so it overloads the method in both of them. So we don't have a problem. And the runtime is going to overwrite the method. So that is how you can be able to deal with method overloading and be able to go through. Make sure to understand it. Any way you don't understand it, feel free to pause the video and listen to it and try to do it yourself. You're going to have it, or otherwise you can do what? You can reach out to me and I'm going to help you to understand better. And don't forget to keep a like at this video, like the video, subscribe to the channel. You can keep a comment in the comment section. I will gladly attend to you. Thank you so much. Let's continue to the next. So with so the next thing we are going to be seeing is our Python encapsulation. So encapsulation is just handling of data or the attributes and the methods, which are the functions. When you hear me calling methods, know that those are the functions within a class, restricting access to some components to control interactions. So a class is an example of encapsulation, as it encapsulates all the data that is the member functions or variables, etc. You can name them. So the types of encapsulation that we are having here, we have the public members, which access from anywhere. We can access them from anywhere in the program. We have the protected members that can access within the class and its subclass only. And then we have the private members, which can be accessed only within the particular class. So we are going to be seeing these three things to understand how it works, to see them, to understand. In this encapsulation, it's like binding, like covering it, joining things together and working. So this is the program we are going to use to understand encapsulation. So now what is it? I'm having a class doc. In this class that is called doc, what happened? I'm having attribute encapsulation example. So we have methods here. We have the init method. I've given the three attribute name, breadth, and the age. So the self.name, so this is the public attribute, right? So the name, self.name, is a public attribute that we are giving. Everybody knows, yeah, it's a dog, the name of it, whatever the name you're given. Then the self.breadth, I'm giving as a protected. So because I want to use this to show the three things, the public, protected, and the private attributes. I want to show you how these three things work that I just explained at the same time. So I've decided to say, let this one be the public attribute, this one be the protected attribute, and this one be the private attribute. This one can be accessed anywhere in the program. This one can be accessed only in the class and its subclasses. This one can be accessed only in a particular class because it is private. Now, I'm having methods. Now I'm declaring now the public method. The first one is a public method. That is get info. I'm getting the information. I say, I want you to return what? Formatted string, the name, the breadth, and the age. So I'm using the formatted string here. You know this, right? If you don't understand this, go back when we learn. Go to the class, to this is the class when I was teaching about strings. You're going to understand this. That should be part what? I think it should be part 4 or part 3. I don't know. You can go back there to understand the formatted string. So the name is, this is the name, which is self.name, the breadth, self.breadth, and the age, which is self.age. So that's the age. We are getting the three things we are getting, the attribute that is going to return to us in this public method. And then now we are using the getter and the setter for private attribute. We want to get the getter and setter. We want to get and set for the private attribute. Private attribute we want to know is the age. We know very well, right? The age is a private attribute. So the age is going to return the self age, which that is itself.age. And then we have to set also the age, which is what? We say, I'm giving the condition here. If the age is greater than 0, then it should give us the age, right? It should give self.age, and else if the age is less, else means that it should be less than, right? It should be something different from that. So it should be invalid age. The else is the false part, and this is the true part. So I've set a condition there that I've set it, and I'm getting the age, and I'm setting a condition also for the age. Coming now, I'm creating what? This is in, I'm creating an object of this particular class, which is the dog. So it's calling the object of this class. These are the attribute of it, body. And then we have what? I'm giving it as Labrador, and the age is 3 years old. So accessing now the public method, the public members. I want to access the public member because the name is public. Remember what I said here, that the name of the class I've given as a public attribute. So I want to access it. So the print I said dog.name is going to be accessible. Now accessing the protected members. If I say I say dog.breed, dog._breed, access but discourage outside the class. Accessible but discouraged outside the class. You get it? Because it is a protected member. And then accessing the private member using the getter. So I'm going to access it. I cannot access it directly like the way I just do this. It won't go. Like how you're just getting this ones. I just say dot. I gave it directly. I got it, the breadth to get it. Now we can access this, but it is advised, is discouraged outside the class, but you can access it even though it's a protected member. But now for the private, I cannot just go and do the same thing that dog dot __h. It will not work because it's private. I must only access it through the getter function that I gave here, the method. Because to access that age, so through this, it's going to go to get this particular method, where in that method, I'm going to get the age. That is why I said doc, they use the object dot, the get age. Can you see? Now, it's going to give us. Now, if I want to modify, for example, for this, let me just run this first, and let me comment this. This part is not existing for now. I've commented it. Let's run this program and see. You see? Body, Labrador, 3 years old. Because now, and if this is, look at it. Let me show you something also. I'll rerun this. You see, body, Labrador. I can get it directly because this is a public attribute. I can get it anywhere in the class. I can access it. This is protected, but because it belongs to this class and the subclasses, I can get it, but it's not encouraged for me to get it directly like this. You get it, but I can still get it. But now, with this private, if I do like this, look at what is going to happen. If I remove this, I want to get the private. I'm just going to take this off. I'm just going to give it also the same way. Sorry. H. I want to get the H directly like that. This is a private. Let me just uncomment this. Remember, this is a private. This is a private attribute. You see, it's already throwing the error here. Now let's rerun this and see. Now let's rerun this and see. You see, it's throwing an error. You see, that is how it's throwing an error. Why? You see, attribute error, because this is a private attribute. It's not a public attribute. It's not a protected attribute. That's why you're saying that object has no attribute this. You see, it is throwing an error, because if you see here, this is the attribute we are having here. Word. One thing, we cannot access it directly. You cannot access outside the class, but it is what? Private. That is why we have to go via what? We have to go via the get h method that we define, we declared. That is, so if I do it like this, I open this now, I'm uncommenting this. I just uncommented this, and then I run it again. You see, we are going to have it now, Labrador, which is 3 years old. Now, let me just collapse that. Now, I'm going to do what I want to open here, and I'm going to open here to modify. Now I want to modify the age. So I said modifying private members using the setter. So using the setter method that we gave here, this setter method to set the age, because I gave a condition here. Now I want to modify it here. I'm saying that doc, I'm saying the doc set underscore this. I'm modifying it to be 5 years old. Print now the get info. I'm printing it. Now look at it. Let me print this. Can you see? It's giving me now the new thing that is coming here is telling me, it says name is body, the breed is Labrador, and the age is 5. Without also, remember, Python prints line by line. So it's going to print whatever you have given before, and then it's going to print this. Can you see how beautiful it is? Understood, right? Both the public method, the protected method, and the public attribute, protected attribute, and the private attribute, to see how accessible they are. If this is clear, let's continue to the last part of it that we have for today, which is the data abstraction. And before that, make sure you have liked, you have subscribed to the channel, and you're sharing to others, and then you're commenting in the comment section. Just click the like button. Always click it, click it. It will not kill you just to click the thumbs up. That thumbs up is called the like button. Just click it. That is all. So the last thing we are going to be seeing is that this oops in Python, we are going to be seeing is data abstraction. So data abstraction simply means to hide the internal implementation details while exposing all of the necessary functionalities. So it helps to focus on what to do rather than how to do it. So we have types of abstraction. We have the partial abstraction and the full abstraction. So the partial abstraction, abstract class contain both the abstract and the concrete method, while in a full abstraction, the abstract class contains only the abstract method. And we are going to see how we are able to use it using the keyword, the abstract keyword. So the data abstraction, that is the last one for this thing to do before we enter the question and answers. So from ABC, import ABC abstraction method. This is just for you to import from Python libraries to how to import this. Now, class is doc. I say I'm giving that the doc class is doc, which is ABC. So abstract class, this is the abstract class. This is the abstract class that I've just defined. And then use the initialize method. I'm just giving one attribute, which is what? Which is a name attribute. You get it? Now, an abstract method. You see, this is the keyword. These are things that you cannot change. So I'm having a method here, which is sound. The sound of it is an abstract method, which is a sound which is passed. And then I'm having what? Another method here, which is display name, which is what? The concrete method. So this is the abstract method. This is the concrete method, the way I explain the difference to you for you to see the various methods that I explained there for you to understand how it goes. And I'm saying print. I'm giving here the formatted string. I say I want to print the name. I want to print that particular name, right? The name object of that class, the attribute name attribute of that class. So doc's name is so the self dot name, which is it. And then I'm given another class, which is a Labrador doc. The Labrador doc. I say partial abstraction. This is partial abstraction, showing example of partial abstraction. So the defs having the sound class, which is print Labrador. You get it? So the class, now I'm having another class which is Beagle dog, which is a partial abstraction. So the sound method here, I'm using what? Beagle back is backing. Back is backs the dog back. You get it? Now coming out to call the attribute of that class using the object. We need to create an object of the class. I've created the object which is dogs. And then I'm having here, so I'm having a list of the various of the two this thing. The two, we're having Labrador and we're having what? Beagle. So I have here Labrador, which is body, and then the Beagle, which is Charlie. These are the names I've given to those dogs. So I'm taking a follow. I say for dog in dogs, I said dog dot display name. So I call the concrete method here. Here I'm calling the concrete method, and here, so I'm just simply call to implement what implements the abstract method because I have the abstract method here. I want to implement the abstract method and I'm also calling the concrete method. Hope this is clear. When I run this program, look at what happened. Dog's name is Buddy. The Labrador woof. The Labrador is woof. Then the dog's name is Charlie. The sound of it. This the Labrador is woof. The Beagle is back. It backs. Why the Labrador is? If you have heard dogs like this, right? When you hear them when they're crying, you hear the other one you hear is backing. That is just it, the sound they are making. So I hope this is clear. I hope everything is clear about this. If there's any question on anything that is not clear, so I've come to the end of this, the Python OPS, the object-oriented programming in Python. So now the next thing we are going to be seeing is answering the questions. So if there's anything, take time to go through this. Practice. If anything you don't clear, is not clear, it's not understandable, it's not understood, let me know. Okay. So now we are now entering the Python OPS frequently asked question and answers in the interview, and for you to also know to be able to understand what we just studied. The first thing is, what are the four pillars of object-oriented programming? OPS means object-oriented programming Python. So there are four pillars of the object-oriented programming, the OPS in Python, and generally in programming, and generally you will see it in all programming language. The four pillars, the first one we have encapsulation. In any order, I put in any order, it doesn't mean that that is the most important. No. Encapsulation, abstraction, inheritance, and polymorphism. These are things that we have just seen today also. So encapsulation simply bundles the data attributes, the data or the attributes and methods, functions that operates on the data into a single unit. Then we have the abstraction. The abstraction is hiding the complex implementation data and providing a simplified interface. Then we have the inheritance, as I explained. The inheritance allows the class to inherit attributes and methods from another class, promoting what code reuse. As I told you, the most important thing of inheritance is code reusability. Now we have the polymorphism, which is using a single interface to represent different data types or objects. That is it. So the next the question we have here is object-oriented programming used in Python? The answer is yes. Python fully supports what object-oriented programming, which is an OP concept, which is the classes, as we just saw, what we just saw now, classes, objects, inheritance, encapsulation, polymorphism, and fundamental features of Python. The next question is Python 100% object-oriented? Python is a multi-paradigm programming language, meaning it supports multi-programming paradigms, including what? Procedural means that it is procedural language, functional, and object-oriented programming means procedural programming, functional programming, and object-oriented programming. Python is supporting all of them. So it does not rely only on object-oriented programming. So why Python is predominantly object-oriented, it also allows for procedural and functional programming style, which is beautiful, isn't it? That is good. Now, the next thing we are having is what is the init in Python? I explained this and I'm going to explain it again. Init, this init method, this init is a method in Python. It is a special method, which is a constructor in our Python classes. So it automatically called when a new instance or object of a class is created. That is when that init method is called. So the primary purpose of it is to initialize the object's attribute or performs any setup requirement for the object. So like I say, for example, we have a class here, which is what? Class, my class. So we use the class at a class keyword to define the class, my class. And when we take this init, we take the def init of method to initialize. So you see, these are the attribute of the class that we are initializing. So this self parameter, we know it points directly to the object in that particular class. That is why we have self dot argument one is argument one, self dot argument two is argument two. We already saw this. This was an example to show. And what is a super method in Python? This is an equation that is always asked. Also, super method in Python is used to call the method of a super class. So which is a parent class from a subclass, a child class. So it returns a proxy object that delegates method calls to the superclass. So this is useful for accessing inherited methods that have been overridden in in a subclass. For example, if you look here, we have the class, the child class, the parent class. This class is inheriting from where? The parent class, right? That is why the parameter is the parent class. So we are initializing two arguments from it. We use a super method to initialize those arguments. Means it calls the init method of the parent class. So that is why you see the argument of it is coming from the parent class. Hope that is clear. The next question we are having is, why is self used in Python? This keyword that I told you, that is a self keyword that I said it points to the object of the particular word. It points directly to the object of the particular class. And why is it used in Python? Now we are going to understand. Self is a convention in Python used to refer to the instance of that class or the object of that class itself. So it is a first parameter of our instant method and refers to the object calling the method. It allows the method to access and manipulate objects, which are the variables that belongs to that particular instance. For example, we have here a class which is my class. You see, the init method we are having, we're initializing the name, and the first distinct object in that class, the first attribute in that class is always the self. And this self is the one that is what pointing directly to the object of the attribute of that class, which is what the name. So we see we have a greet self. So we return hello self name. Miss is going to tell me that you say if your name is Nesh like mine, it's going to say hello Nesh. When I create this particular object of this class, of this my class, and I have the name Alice. So when I print this, the output is going to come out as hello Alice. Can you see? So these are some of the questions you can have here. This is helpful, and there is more. You can check in this same check in also in our class in the same program in this same channel in our Code Global. If you check the shorts, you're going to see good questions and answers, Python programs that are going to help you also to learn Python by coding. And these are questions and answers that are being taught. You learn them to help you to understand when you go for your interview. Question and answers. These are answers you answer in the interview, go for interview. Okay, so try to make use of them and use them to help yourself. So we have come to the end of the class today. Hope it is helpful. Remember to keep a like in this video, subscribe to my channel, and hit that notification bell. And also to all my returning subscribers, you're highly welcome. How are you? You are the global stars. You are the global stars that we are rocking together because of you. So please remember to subscribe and watch, and always remember to watch till the end. Share with others, like, subscribe. Okay, thank you guys so much, and see you in the next part of it, which is a part 10 of it.